Let's take a look at another functional equation. So this one is a bit more complicated, and as you can see here, we have a n which is a positive integer or a natural number, and find a monotone function f from real to real number such that f of x plus f of y equals f of x plus y to the nth power. So first of all, we would like to, from the original equation, we can just substitute x equals to 0. X equals to 0. So we will have f of 0 plus f of y equals f of x plus, f of 0 here. F of 0 plus y to the nth power, which means that it is nothing but f of y equals f of 0 plus y to the nth power. So let me denote this one to be equation 1. So the next step is, as we can see, f is a monotone function, and monotone function means increasing or decreasing. Increasing or decreasing. So f is monotone, and actually f of f should be monotone. Actually, monotone is quite enough, and actually it is only possible to be increasing function. Although whether it is increasing or decreasing is not really important in this problem, but actually we can really know that f of f is actually increasing, because if x is larger than y and f is increasing, which means that f of x should be larger or equal to f of y, and f of x is larger or equal to f of y. And for the other case, if f is decreasing, then in this case f of x will be smaller or equal to f of y. And if we will apply f again, then we will have f of x is larger or equal to f of y, which means that f of f is increasing, which is stronger than monotonic. But actually, monotone is quite enough, but actually we can see that in equation 1, f of y equals f of 0 plus y to the nth power. So this part is increasing or monotone function, and this is nothing but a constant. So this part must be monotone. But we see that if n is even number, then y to the nth power is not monotone. It's not monotonic. When n is odd number, then y to the nth power is monotonic. For example, if n is 2, then y squared is nothing but a parabolic. And if n is an even larger even number, then this curve is be sharper and sharper, which means that this is not a monotonic. This is not a monotonic function. But for n is odd number, for example, if it is a first order, y to the first power, which is a linear function, or if n is 3, so the curve like this is still a monotonic function. So we conclude that n should only be odd number. So the next step is to, let me see, so is to find f of 0, because for this function, this one is not good for us. If we can eliminate it, it will be much better. So let's see, in the original equation, in the star equation, we can let x equals to 0 and y equals to f of 0. So yeah, so we will have f of 0 plus f of 0 equals f of 0 plus f of 0 quantity to the nth power. So this is 0. So the left side will be f of 0. And in equation 1, we can plug in y equals to 0. We can plug in y equals to 0 equals 0. So we will have f of 0 equals f of 0 plus 0 to the n power, which is 0. So we will have this expression. So in this case, we can eliminate this term and this term because they are actually equal to each other. So we can eliminate them. So in this case, we have f of 0 to the nth power, which is 0. So we can have f of 0 equals 0. So next, we can simplify equation 1 into f of y equals y to the nth power. And we may call this one 1 prime, equation 1 prime. So next, when we make use of equation 1 prime, we can evaluate f of y. So this can be evaluated in two ways. You can look at this equation, you can apply f on both sides, which means on the left hand side it is 3 times function f of y, and then right hand side will be f of y to the nth power. Or you can substitute y to be f of y. So this one will be f of y quantity to the nth power. And in this one, we can plug in y equals 1, so that we will have f of 1 to the nth power, which is 1, equals f of 1 quantity to the nth power. So there will be 3 possible values for f of 1. So f of 1 could be 0 or plus or minus 1, because n is n is odd number. N is odd number. So only this value is possible. So we have 3 cases. So let me check for case 1 if f of 1 is 0. So in this case, in star equation, we plug in y equals 1. Y equals 1. So we have f of x plus f of 1 equals f of x plus 1 to the nth power, which is 1. So this one is 0, which means that the left side will be f of x. So we cancel f of x here and here. So we'll have 1 equals to 0, which is a contradiction. So we discard this one. So the other case is f of 1 equals 1. So still in the original equation, we plug in x equals y equals 1. So we have f of 1 plus f of 1 equals f of 1 plus 1. This is 1, so this is 2. This is 1, this is 2, which means that f of 2 equals f of 1 plus 1, which is 2. And in 1 prime, we can plug in y equals 2. So we have f of y, f of 2 equals 2 to the nth power. So this one is 2. So the left side is f of 2, which is 2. So equals 2. In this case, n can only be 1. It can only be 1. So for the third case, f1 is negative 1. So in the original equation, we plug in y equals 1. Y equals 1. So we'll have f of x, f of x plus f of 1 equals f of x plus 1 to the nth power, 1 to the nth power, which is 1. So in this equation, we firstly plug in x equals 2. Let me see. Or we can write it as this one is negative 1. So we have f of x minus 1 equals f of x plus 1. So in this one, we plug in x equals 2. X equals 2. So we'll have f of 1 equals f of 2 plus 1, which means that f of 2 is f of 1 minus 1, which is minus 1 minus 1, which is minus 2. And then we can plug in, let me see, x equals 0. X equals 0. So we have f of x minus 1, which is minus 1, equals f of 0 plus 1, which is 0 plus 1, which is 1. And then we can plug in x equals negative 1. So we have f of x minus 1 minus 1 minus 1, which is minus 2, equals f of minus 1 plus 1, which is 2. So going back to the 1 prime, we plug in y equals 2. So we have f of 2 equals 2 to the nth power. So this one is minus 2, which is here. So f of minus 2 is 2. So equals 2. So we also can conclude that n equals 1 is the only possible value for n. Yeah, so overall in these three cases, f1 equals 0 is not possible. No matter f1 equals 1 or minus 1, n should be 1. So in this case, the star equation can be simplified as f of x plus f of y equals f of x plus y to the first power, which is y. And also 1 prime is like f of y equals y. So in the star equation, we substitute y by f of y. So it will become f of x plus f of y equals f of x plus f of y. So this one is nothing but y. So we have f of x plus y equals f of x plus f of y. So this one is a Cauchy equation. And with the f is a monotone function. So we can conclude that for f is from real number to real number, f of x should be f of 1 times x, which is, here we already know that this one is not possible. F of 1 can only be plus or minus 1, which means that it can only be plus or minus x. So let's check. And here n is 1. For n to be other value, there will not be any solution. So let's double check f of x plus f of y equals f of x plus y to the nth power. So f of x plus f of y would be f of x plus or minus y. So in this case, it would be, let me see. If it is positive, it will be positive. Positive. If it is negative, it will be negative. This way. Yes. So for the right hand side, f of x plus y to the nth power given n to be 1 would be plus or minus x plus y. So both are the answer. So finally, we can conclude that f of x to be plus or minus x will be the solution to the original functional equation. So, and this is the end of this video.